Hello friends, welcome to the channel. In continuation with the topics related to fluid mechanics, in today's session, we are going to throw light on flow through siphon. Now you can see the diagram of a siphon. Now what is a siphon? Siphon is a long bent pipe. Now you can see here. So this is a long bent pipe which is used to transfer liquid from reservoir. So there is a reservoir A and reservoir B, and the elevation of reservoir will be at a higher side, and the B reservoir will be at a lower side. Now, the construction is these two reservoirs are separated by a hill. So you can see here, these two reservoirs are separated by a hill. That's why the pipe is laid like this. Uh, the point C, which is the highest point of the siphon, is called as the summit. Now, you can see here, as per the construction, the point C is above the free surface of the water in the tank A, and this distance can be said to be small h. So small h is the distance of free surface of water in tank A and the summit. Okay, so the pressure at point C will be less than the atmospheric pressure. We can easily find out theoretically what may be the pressure, but theoretically the pressure at point C can be reduced up to minus 10.3 meter of meter of H2O column. Now, but this value is theoretical value. Actually, the pressure can be only reduced up to minus 7.6 meter. So we can get the absolute value. Absolute value of the pressure will be 10.3 minus 7.6. That will be 2.7, 2.7 meter absolute. Now, friends, if this pressure at C falls below the value, that is 2.7 meter of water absolute, the gases which are present in the water, dissolved gases and other gases, air that is present in the water, would come out from the water and will collect at this point of summit. And this way the flow of the water will be obstructed. So there will not be flow of water. So that's why this condition should be taken into consideration while designing this siphon. So that's why what may be the application or uses of this siphon system. So this siphon can be used uh, where uh, we want, as per the diagram, we want that the uh, transfer of water, transfer or carrying water, carrying water from one reservoir to another reservoir, from one reservoir wire to another, another, separated by hill, separated by hill. Or we can use this siphon. Uh, to take out the water from a tank, to take water from tank, to take water from tank which has no outlet, with no outlet, or uh, we can use it to empty a channel, empty a channel, channel uh, which is not provided with, not provided with, with any outlet source, any outlet sluice, any outlet sluice. So these are the possibilities, these are the cases when we can use this siphon. Now, friends, there are some simple numericals which are based on this siphon. Let's try to understand these numericals. Let's try to solve these numericals so that we'll get the idea related to the slide siphon. Now this is the numerical that we are going to understand first. Let's talk about this numerical. A siphon of diameter 200 millimeter. So if we look at the things which are given in the numerical, just 1 minute, let me adjust, let me do the adjustment so that you can see the numerical. Otherwise, yes. Okay. So a siphon of diameter 200 millimeter connects two reservoirs having a difference in elevation of 20 meters. The length of the siphon is 500 meters and the summit is 3.0 meter above the water level in the upper reservoir. The length of the pipe from upper reservoir to the summit is 100 meters. Determine the discharge through the siphon. Also the pressure at the summit. Neglect minor losses. The coefficient of friction is given, small f is equal to 0.005. Now let us simple first draw the diagram. So this can be said to be the reservoir one. Then there will be a siphon and there is a reservoir two. So we'll note it down, reservoir A, and this is the reservoir B, and this is the point of summit. Okay, so as per the numerical, if we go to the numerical, we can easily understand what things are given. So here, small d is given 200 millimeter. So let's convert it into meters, 0.2 meter. Now next thing is the difference in level of the two reservoir is given. So if this is the level of reservoir A and so this distance is given and that distance is 20 meters. So let's denote it by capital H, so 20 meters. The length of the cipher is given, so capital L can be said to be 500 meters. Now, what else things given in the numerical? The height of the summit from the upper reservoir. So this distance is given. The distance which we say small h. Small h is equal to 3.0 meters. Also, with this, the distance between siphon. So this distance, the length of the pipe from upper reservoir to the summit is given. So let it L1. So the value of L1 is 100 meter, and the value of small f is equal to 0.0005. That's all things are given, and we are asked to find out the value of Q, that is the discharge. Now, understand friends, for the numericals which are related to the siphon, uh, if the things which are related to the minor losses are not given, so we can neglect the minor losses. So neglecting minor losses, minor losses, this can be the first statement. So that's why for solving this numerical, let's go to the Bernoulli's equation. So let's apply Bernoulli's equation for A and B. Because if we want to find out the value of the discharge, what we'll need the value of the velocity. So that we can find out with the value of the discharge, and for finding out the value of the pressure at the summit, uh, we need to apply the Bernoulli's equation to the uh, A and C. So let us apply the Bernoulli's equation to point A and B. So the equation is very simple. So P A by rho G plus V A square upon 2G plus Z A is equal to P B by rho G plus V B square upon 2G plus Z B plus the losses. So loss of head due to friction between A and B. Between A and B. So to find out this loss of head due to friction, we can use the Darcy Weisbach formula. Weisbach formula. Understand, friends? If the minor losses, if the information related to the minor losses is given, so what we need to do? We need to uh, uh, find out the minor losses also. But in this numerical, the things are not given, so that's why we need to apply the Darcy formula. Now let's move to the next part. So PA, pressure in the tank A, is the atmospheric pressure, and PA, pressure in the tank B, will also be the atmospheric pressure. So PA by rho G and PB by rho G will be having the same values. So I can cancel out these two things. Also, the water in the tank A is still and water in the tank B is also still. So I can say that the value of the water in the tank, velocity in the tank A and velocity in the tank B will be 0. So that's give me, if I apply these things, so ZA equal to ZB plus the head loss due to friction between A and B can be found out by formula, so HF, right? So now ZA minus ZB gives me the formula for HF is equal to 4 FL V square by 2GD. So uh, now here ZA minus ZB uh, here is given. So as per the numerical, the difference in elevation of A and B is 20 meters. So ZA minus ZB can be written as 20 meters. The value of small f, so int is equal to 4, small f 0.005, that is the value of small f. The length of the siphon is 500 meters. Value of velocity is not known, so I can use this value v square. It gives 0.20, that is the value of diameter into 2 into 9.8. Okay, so if we put these values, uh, if we calculate, we can get, so v equal to 20, and the value of this bracket remaining things can be found out to be 2.548. So v square is equal to 20 divided by 2.548, or v is root of 20 upon 2.548. The value of velocity that I am getting is 2.8 meter per second. Friends, solve this numerical if you are following me. Then we want to find out the discharge. So Q is equal to velocity into area. Area of the pipe is pi by 4 into d square. So velocity is 2.8 and the area is pi by 4. The diameter is given, so 0.2 square. So we are getting the discharge as Q is equal to 0.0879 meter cube per second. Now this is the value of the discharge that we have found out. The next thing is they are asking to find out the pressure, at the summit. So we are asked to find out the pressure at summit. Now friends, understand that to solve the numericals which are related to Syphon, only two formulas that we need to know. First is the Bernoulli's equation, and second is the Darcy formula for head loss due to friction. So let us applying Bernoulli's equation. equation for A and C. So that will be PA upon rho G plus VA square upon 2G plus ZA will be equal to PC upon rho G plus VC square upon 2G plus ZC plus HF1, we can say, head loss due to friction, that is between A to C. Now friends, the atmospheric pressure can be uh, written as 0. So this will be 0. The velocity in the tank A is 0, right? And uh, we are measuring the distance with reference to A. So A is our reference point. That's why the value of ZA can be also 0. So we are getting 0 is equal to PC by rho G. That value we want to find out, that is unknown in the numerical, plus VC square upon 2G. Now the velocity that we found out by applying the Bernoulli's equation between A and B, that velocity is the velocity of fluid in the pipe that will remain same at any point in the pipe. So we can say at point C, the velocity will be 2.8 meter per second. So 2.8 square upon 2 into 9.81 bracket plus let C, the distance of point C from A is 3 meters, so 3 meters plus the formula for HF1. Okay, so the formula for HF1 can be written as 4. The value of F is given 0.005. The distance, the length of the pipe from A to C is given in the numerical, that is 100 meters, and the value of velocity we are using 2.8 square divided by the diameter is 0.2 and 2 into 9.81. So friends, here the value of PC by rho G, that is pressure head, is unknown. So 0 equal to PC by rho G. What values I am getting here is 7.399. That is PC by rho G is equal to minus 7.399 meters. Now understand friends, in this, while solving the numerical, the atmospheric pressure is not mentioned. The atmospheric pressure is not given in the numerical. So that's why we are saying it as a 0, and that's why we are getting the value of PC by rho G as minus 7.399 uh, meters. Now, before the session, we had a discussion regarding the minimum pressure. So the minimum pressure in actual practice uh, should be minus 7.6 meters of H2O for the um, operation uh, or flow of fluid in the siphon. Now, whatever the value we are getting, this value uh, is following the same thing. It means that there will be flow of water from point A to point B. If we want to find out the absolute pressure, so we can get the absolute pressure of water, and that value will be more than 2.7. So it means that the siphon will operate. Okay. So now, friends, that's all for the points which are related to siphon. I tried to cover the theory part and one numerical, and in few of the numericals, the atmospheric pressure will be given. So I need to use the atmospheric pressure values for PA by rho G, PB by rho G, etc. While calculation. And in those cases, the value of the pressure PC by rho G you will get as 2.6 positive value 2.6, 2.5 something, 2.7, 2.8 like this. So that value will be absolute value we are getting, right? So that's all for this session on the siphon. We'll meet in the next video related to the new topic on fluid mechanics. Thank you, friends.